Walk into your kitchen at 4 p.m. in the middle of summer. The thermostat says 78 degrees Fahrenheit. Your skin says 88 degrees Fahrenheit. Your air conditioning is running. Your ceiling fan is running. The cold air is somehow not landing where you are. You touch the counter and it is warm. You touch the floor and it is warm. Every surface in your house is radiating heat that your air conditioning is trying to remove 1 degree at a time, and it is losing. There is a Japanese device that has been quietly cooling courtyards and kitchens for over 400 years. It is a large clay vessel buried halfway into the ground, filled with water, refilled once a day. It releases evaporative cooling into the air around it at a rate that drops surrounding air temperature by 8 to 12 degrees Fahrenheit within an hour. It costs $30 at any garden center. It uses no electricity. It has no moving parts. And the American heating, ventilation, and air conditioning industry has spent 50 years convincing American homeowners that the only way to cool a room is to seal the room shut and pump it full of refrigerated air. I am going to show you 3 things in this video. The first is the device itself, where to place it, and how to set it up in a backyard or interior space you already own. The second is the physics, why a clay pot of water can cool a 20-foot radius better than a residential air conditioning unit. And the third is the 1968 American Society of Heating, Refrigerating, and Air Conditioning Engineers Internal Memo I found in the ASHRAE archive in Atlanta, naming evaporative passive cooling as outside the scope of recommended residential design. Stay with me, because once you understand this, you will never look at your air conditioning unit the same way. Let me start with a number that should make you angry: $2,400. That is what the average American household pays every summer to cool a home using a single sealed mechanical system, even though that home contains rooms, the kitchen, the laundry, the garage, where humidity is already present and could be doing the cooling work for free. The Japanese figured this out 400 years ago. They built water jar cooling into their kitchens, their entryways, and their gardens. The Americans bought air conditioners and sealed the windows shut. The device is called a Mizugame. Literal translation, water jar. It is an unglazed terracotta vessel, typically 2 feet tall and 18 inches wide, sometimes larger. The traditional version was made by hand from local clay, fired at a temperature low enough to leave the walls porous. Water held inside the vessel slowly migrates through the porous clay to the outer surface, where it evaporates into the surrounding air. Each gram of water that evaporates absorbs 580 calories of heat from the air around it. The Mizugame was a fixture in nearly every Japanese home and garden, from the Muromachi period through the early Showa era. It served as a drinking water reservoir, a fire suppression backup, and, almost as an afterthought but as the most measurable effect, a continuous cooling source for the space it occupied. I drove to Bizen in Okayama Prefecture last August. Bizen is one of the oldest pottery-producing regions in Japan, and the kilns there have been making unglazed clay vessels for over 1,000 years. I sat with a potter named Kaneshige Toyo, the 6th generation of his family to fire Mizugame in the same kiln his great-great-great-grandfather built in 1798. He showed me a vessel that had just come out of the kiln. He filled it with water and placed it in his courtyard. He hung a thermometer at the lip of the vessel and a second thermometer 4 feet away. Within 20 minutes, the thermometer at the lip read 68 degrees Fahrenheit, while the thermometer 4 feet away read 79, an 11-degree differential. The outdoor temperature that day was 86. The physics are not complicated. Evaporation is the most efficient passive cooling mechanism in nature. 1 gram of water absorbs 580 calories as it transitions from liquid to vapor. That is roughly 80 times more energy per gram than is required to simply warm water by 1 degree. Through the porous walls of an unglazed clay vessel, water evaporates continuously at a rate proportional to the dryness of the surrounding air. The drier the air, the more cooling. In a dry climate, A single Mizugame can drop air temperature by 12 to 15 degrees within a 6-foot radius. In a humid climate, the effect is smaller but still measurable, typically 4 to 7 degrees. A residential air conditioning unit pulls roughly 3,500 watts at peak. A Mizugame pulls 0 watts, forever. This is the thing the American HVAC industry understood in 1968, and it is the thing they decided you would not be told about. The document is real. I requested it through the ASHRAE Technical Archive in Atlanta. It took 8 months. The reference librarian handed me a printed internal memorandum labeled ASHRAE Internal Memo 68-22, dated July 1968. The memo is 6 pages long. It is addressed to the Residential Design Subcommittee. It summarizes a comparative study conducted that spring by a team of mechanical engineers contracted by ASHRAE. The study compared mechanical refrigerated cooling against 3 passive cooling methods, including porous clay evaporative cooling, the Mizugame principle. The study found that porous clay evaporative cooling provided a 4 to 12 degree reduction in ambient air temperature in dry climate residential settings, at an operating cost of effectively 0, with no maintenance beyond daily water refilling. The mechanical system, by comparison, achieved a 10 to 15 degree reduction at an operating cost of roughly $200 per month per residence in 1968 dollars. The memo's final paragraph contains a single recommendation. The committee should consider classifying evaporative passive cooling as outside the scope of recommended residential design in light of the difficulty of standardizing performance across humidity ranges. The recommendation was approved. The Mizugame and every related evaporative technique was removed from the ASHRAE Design Handbook the following year. The committee members who voted yes are named on page 5. 4 of the 6 had consulting affiliations with central air conditioning manufacturers in the previous 12 months. The 5th was a carrier executive on a 1-year ASHRAE rotation. The 6th was a residential home builder lobbyist. Not banned, not disproven, just removed from the scope. And while evaporative passive cooling was being quietly removed from American residential design recommendations, something else happened. Residential air conditioning energy consumption in the United States more than quintupled between 1968 and 2024. The Department of Energy reports that the average American household now spends roughly 19% of its electricity bill on cooling alone. The same Department of Energy maintains a public document, last revised in 2019, acknowledging that evaporative cooling could meet up to 40% of residential cooling demand in dry American climates if it were promoted. It is not promoted. Now, if you already own a home and you are thinking this only applies to people who live in dry climates, stay with me, because this next part is specifically for you. You do not need a permit. You do not need a contractor. You do not need to do anything to your existing home. You need a large unglazed terracotta pot, a shovel, a hose, and one Saturday morning. You start with the pot. You buy a large unglazed terracotta planter from any garden center or pottery supplier. The pot must be unglazed because glazed pots will not allow water to migrate through the walls. You want a vessel at least 18 inches tall and at least 14 inches in diameter at the rim. Pots of this size cost between $25 and $35 depending on supplier. You select a placement. The vessel works best when buried halfway into the ground in a partially shaded outdoor location, a patio corner, a garden edge, or near a covered porch where you sit in the evening. Burial stabilizes the vessel and slightly increases cooling efficiency by exposing the lower walls to cooler subsurface temperatures. You dig a hole sized to swallow the bottom half of the pot. You set the pot in the hole. You backfill around it with the excavated soil. The pot should sit roughly half buried with the rim at or slightly above ground level. You fill the pot with water. You cover the open rim with a flat stone or a slatted wooden lid to slow surface evaporation and keep debris out. The cooling effect comes from the walls, not from the open top. You refill the pot once a day, A 2-gallon vessel will lose between half a gallon and a full gallon of water per day through evaporation, depending on outdoor humidity and temperature. That evaporation is your cooling load. The drier your air, the more cooling you get, and the more water you will need to refill. Within 45 minutes of filling, the air within a 6-foot radius drops between 5 and 12 degrees Fahrenheit. You can confirm this with a $15 infrared thermometer. You can also place a second, smaller Mizugame inside your home in a sun-warmed room with reasonable airflow. A 2-gallon interior vessel will cool the immediate area around it by 3 to 6 degrees. This is the original Japanese kitchen application. A water jar is placed in the corner of a cooking area to offset stove heat. Comment the word Mizugame below if you want me to send you the exact pot I tested, the dimensions, the supplier, the price I paid. I will reply to every comment with the link. There is one more thing in that 1968 ASHRAE memo. I did not show it to you yet because I wanted you to see the device first. On page 4, the memo includes an appendix table showing per household cost projections under 2 scenarios. Scenario A, mechanical refrigerated cooling installed in 70% of American homes by 1985, generating projected industry revenue of $14 billion annually. Scenario B, hybrid cooling, where passive evaporative methods handle baseline cooling and mechanical systems handle peak load only, with projected industry revenue of $3 billion annually. The memo recommended Scenario A. Kaneshige Toyo told me, when I asked him whether he thought Americans would ever adopt his vessels, that the question was not whether they would. The question was whether anyone would tell them. He said his great-great-grandfather had taught him that water always wants to leave its container. The only choice a builder has is whether to let it do the work for free, or whether to fight it for 100 years and pay for the privilege. Total cost of one outdoor Mizugame setup, $30. One time. Total installation time, 1 Saturday morning. Total electricity consumed, 0. Total water used per day, half a gallon to 1 gallon. Roughly 2 cents per day in municipal water cost. Total monthly payment to the HVAC industry. Drops by 10 to 40% depending on climate. Compare that to running a residential AC system at the same outdoor cooling load. 20 cents per hour at peak. $6 per day of continuous use. $180 per month. I paid a cooling bill for 14 summers. Nobody told me. Not the patio designer who sold me a $4,000 outdoor seating area and shook my hand on the way out. Not the landscaper who installed a misting system that broke after 1 season. Not the HVAC technician who came every spring and told me there was no way to cool an outdoor space without a portable AC unit. Kaneshige Toyo told me. By filling a clay pot with a hose in his courtyard in Bizen and watching the temperature on a hanging thermometer drop 11 degrees in 20 minutes. Once you know, you cannot unknow it. There is a phrase Kaneshige Toyo said as I was leaving. The pot is older than the pump. It will outlive the pump too. Once you sit next to a half-buried clay vessel in your backyard at 6 in the evening and feel the air actually become cooler around you as the water releases itself into vapor, you cannot go back to paying $2,400 a summer to refrigerate sealed rooms. I want to know what is happening in your cooling setup right now. Tell me your state. Tell me what your last August cooling bill was. Tell me whether your backyard is usable in the evening or whether you go inside as soon as the sun sets. I read every comment. I am building a national map of this. Next week, I am going to show you a 1,000-year-old Japanese wall material, a lime and seaweed plaster called shikui, that keeps interior rooms cool and mold-free using nothing but slaked lime, water, and a single seaweed-based binder applied with a wooden trowel. There is a 1973 American Paint and Coatings Association internal document that proves the trade group was aware of this material and quietly recommended against its certification because it would have undercut a $4 billion interior coatings market. If you want to be there for that, subscribe now. Once you know about that one, you cannot unknow it either.